Welcome to the WisDOT Civil 3D Customizations, What's New Since Last Year session. This class will be presented by Keith Zawinski, the Civil 3D Implementation Engineer at WisDOT. My name is Rachel Burnham with SRF Consulting, and I'll be assisting with the Q&A moderation and have just a couple of notes before we start this session. We want to give a big thank you to all of our sponsors for helping make this virtual workshop happen. We couldn't host this workshop without their contributions, so we want to give them a big thank you. Also, an evaluation link will be provided at the end of this session, and you will get a summary email at the end of the day. You'll need to complete the evaluation to qualify for PDHs, and it'll also help with our future event planning. And now we'll turn it over to Keith.
Hello and welcome to the 2021 ACEC Civil 3D Workshop. My name is Keith Zawinski. I'm the Civil 3D Implementation Engineer for the Wisconsin Department of Transportation. My presentation today is titled WisDOT Civil 3D Customizations, What's New Since Last Year? So we've had a lot of activity on our Civil 3D customization over the past year, and realizing that not everybody reads the What's New file that we put out with each of our updates. You may not realize what we've all done. So just wanted to have a presentation that sort of draws your attention to some of the things that have changed since the workshop last year. Hopefully you'll find something interesting and something that'll make your productivity a little bit better. A couple things about this is that we're only going to be discussing what's new and changed since last workshop. So we're not going to be going into specifics about all of the WisDOT Civil 3D customizations. Again, this is only things that have been added or changed. We assume for this presentation that attendees have had some experience with our customization, so you're somewhat familiar with how we deploy the WisDOT package and a general idea of what it looks like. So getting started, first I want to talk about our redesigned and enhanced user interface, starting off with our WisDOT ribbon tabs in Civil 3D. Just to give you a quick look at Civil 3D itself with the customization installed, you'll notice we have 3 ribbon tabs visible here. We've got WisDOT Survey, we've got WisDOT Design, and WisDOT Sheets. And you'll notice that on all 3 of these ribbon tabs, we have a few panels that are common to each. We've got the support panel, we've got the manage panel, and the view panel. So what's nice about these common panels is they're just useful tools that can be used, for really any discipline. They're not specific to survey, they're not specific to design, and they're not specific to sheet production. One thing that we've done with the redesign of our WisDOT ribbon tabs is we've sort of made them scalable, meaning that, as we develop new tools or the tools in our library change, there's going to always be a place to put these things. With our old design, things were sort of just put on the ribbon tabs, and there wasn't a lot of room for us to expand. So now you'll notice a lot more of these sort of drop-down menus. You can see here we've got one for workspace, DWG project, layer tools. That gives us buckets to put new tools into as we expand our library. So the support panel, just zeroing on that, is just really quick access links. If you have in the support panel, you've got a button to give you quick access to our Civil 3D knowledge base. Also, if you click on that little arrow, it'll give you the option to click on a button that'll take you to our WisDOT Civil 3D Futures page on Trello, where you can submit ideas for improvements to the WisDOT Civil 3D configuration. The Manage panel is really all about managing your project in drawings. The View panel is just really about navigating your model. Gives you a quick way to rotate your view without changing your UCS. There's a button there to return you back to a regular plan view. Moving on to the WisDOT Survey tab. This is brand new. We found that there's quite a few tools geared really towards survey and mapping that it warranted its own ribbon tab. The survey panel is really just general tools for survey. It includes many of our custom reports. So if you're wondering where like all of our custom reports went to, we used to keep those reports in the WisDOT toolbox. Well, now they can all be accessed from some location on the WisDOT ribbon tabs, and vast majority of the reports are found right here on the survey panel of the survey tab. So you can see there's the drop down right there. The mapping panel is really specifically focused on our photogrammetric mapping processes. So probably not a lot here that the everyday user is going to be using, but certainly our central office surveying and mapping unit. These are some tools that they use on a daily basis. Moving on to the WisDOT Design tab. So this really saw a complete reorganization. This is where we see the most change between our previous version of the WisDOT ribbon tabs and this version. And the change is mostly to accommodate a lot of new tools that we've provided in the last year and provide room for expansion. The design panel is, you'll notice it's sort of an object-based organization. And what we're trying to do here is mimic what you see on the out-of-the-box Civil 3D Home tab. So things are sort of arranged the same, where you have in mind, okay, what object am I dealing with? And then you go to that menu and you find the tool you're looking for. The Design Palettes panel is where you access various design palettes for blocks and subassemblies that you use in roadway design. The Analyze panel includes tools that you'd use for making measurements, tools that are useful for quantity takeoff. One tool or report that you've probably used a lot if you're a designer is the WisDOT Culvert and Storm Sewer reports. This is where you would find that. It's located under the QTO dropdown. And the output panel, we really felt like we needed a dedicated area to emphasize the importance of the contractor data packet. We have several tools available for your use to help you with creating the contractor data packet. And that's where you'll find these tools. You'll find them right there on the output panel. And then finally, we have the WisDOT Sheets tab. This is a tab that we had before, and it's mostly unchanged. The sheet creation panel gives you quick access to various sheet building palettes. So for instance, if I'm doing a title sheet, I'd go to that title drop down and find the appropriate palette that gives me all the tools and necessary items that I need for creating a WisDOT title sheet. The annotation panel includes access to WisDOT text styles, multi-leaders, and dimensions. And then finally, we have the plot configuration panel. It includes a page setup palette, so you can quickly import page setups for your plan sheets. And then we include an assign page setups tool that we've had for some time now that makes it easier to assign a page setup to multiple layouts at one time. So that's the WisDOT new ribbon tabs. So I think you'll find them very useful, and the organization much better. It might take you a little bit of time to get used to it, but in the long run, that's going to give us much more, a much better ability to, expand and stay organized at the same time. So moving on, I want to talk about talk a little bit about existing tool refinements we've made. While the functionality of most of our existing custom tools remains unchanged, how you interact with them has been improved. So what we've done is we've created brand new and improved user interfaces. Just a couple samples here on the slide. You see the course table report, slope stake report in our pipe network QTO report. Again, functionality hasn't changed a whole lot, but what we've done is we've just made those interfaces much more consistent with each other. We've simplified the inputs. Perfect example of this is the slope stake report. You used to have to specify, what alignment you're working with. It really wasn't necessary to do that, because if we know which sample lines we want, well, sample lines are assigned to alignment, so you shouldn't have to select the alignment too. So in this case, you select your start sample line and your end sample line and your surface, and you're good to go. Then we've incorporated some additional functionality that folks have requested over the years. You can see on the course table report that we're selecting COGO points, but we can also select arcs. So when you're selecting a course, if you have an arc object between 2 points, you can select that, and the information about that arc will also be included in the course table report. So that's just one example of many that we've done for improving functionality. And then with any of our tools that include a user interface like these, you'll notice a help button. That help button will take you directly to the Civil 3D knowledge base. And not just to the knowledge base, but the specific page on the knowledge base that talks about the tool that you're using. Now let's move on to some of the new tools that we've provided in the last year. One tool that we've provided is called Sync Project Files. This one is found on, I talked about we have the common panels on each of the WisDOT ribbon tabs. So this one is found in the Manage panel. There's a project menu, and you'll find that Sync Project Files button right there. If you're a command line person, you can also access the tool by typing DOT Sync Project Files. And what this tool does is it automates the process of cascading changes throughout your project files. So what you would do is you would input a CSV file. And in that CSV file, you will list each of the drawings that you need Civil 3D to open and synchronize any changes that you've made. If the drawing happens to have corridors or surfaces that need synchronization, you would also specify those objects right here as well, right in the CSV file. So just looking at the example on the screen, you can see that what this is going to do, so we pointed at a CSV file, and then it populates this table. So all this information is in that CSV file. So as you're creating your project, you can add files to that CSV and what you need to synchronize within it. So here it's going to open up an alignment profile drawing, and there's no corridors or surfaces to rebuild there, so it's just going to open it, and it's going to synchronize any references, and then save and close. Then it's going to move on to a corridor drawing, and you can see it has several things to do in that corridor drawing. First, it needs to open up the file. It needs to synchronize references, but then it's going to update this corridor called 4th Avenue Setup ETW. Then it's going to rebuild this next one called 4th Avenue Setup Curb Gutter Profile. Then it's going to rebuild this 25 corridor, and then it's going to rebuild this one called Something Else. Now in this example, I put this something else in here, and you'll find this if you've seen my previous presentations. This will know this something else is a fictitious corridor. So this tool will know that, hey, wait a minute, that doesn't exist, and it'll just let you know and skip it. But then it goes on to my pavement edge lines drawing, synchronizes those references. Then it goes on to my surfaces, and so on and so forth. We also give the option for how robust of a synchronization you want the tool to do. These are both command lines that you can run at any time. The synchronize references command is not as robust as the AECC force synchronize references command. And one of the big reasons we offer both options is the AECC force synchronize references command also synchronizes alignment masks. For some reason, alignment masks don't synchronize with a typical synchronization, so we give both options. Keep in mind, the AECC force synchronize references will take more time than the regular synchronized references. Another thing that affects time is whether or not you synchronize your drawings with WisDOT reference templates. So this gives you that option. If you have no need to synchronize all the styles and things like that for every drawing with the WisDOT reference templates, you can uncheck this box and this tool will run much, much quicker. If it has to do that synchronization, it definitely will expand the timeline for this tool to run. Now keep in mind, this checkbox really only matters if your drawing was connected to those reference templates to begin with. And again, this only has to do with WisDOT reference templates. If you've got your own reference templates, it's just going to do that synchronization if you've got those attached regardless. So the idea here is hopefully this will speed up the process of propagating changes throughout your project when they're made. All right, the next tool is called Create Object Folders. So this one is found in, again, the Manage panel, that common panel, project menu. You'll find the button Create Object Folders. And I want to just sprinkle in demonstrations in here just to break up the monotony and not have to look at my PowerPoint the whole time. So I'm just going to run this tool. So you can see I don't have any object folders in this drawing for various items. And sometimes you want to have a consistent list of object folders in your drawing and maybe throughout a whole project. So what you can do is create a CSV file. So we provide an example CSV file that creates these object folders. And you can find that CSV file in our Civil 3D bundle. So if you're not familiar with bundles or where that's kept, the WisDOT one is kept in Program Data, Autodesk, Application Plugins, and then the bundle name is going to vary depending on your version. Showing 2020 here, so it's WisDOT 2020A bundle. Contents, Windows 2020 ENUS. So create object folder CSV. I'll just open up that file quick. And here you can see that we're listing the various object types. So we got surfaces, the various alignment types, and then a folder name that we want to put in each of these. Now you can see I only have one folder. So we can actually add subfolders here. So for example, refinement. Let's say I actually wanted a refinement and I want a top only folder in there. I'd put that path in there, with the backslash, and you'll see that it'll actually create that entire path. So now when I run this, create object folders, we have a few options here at the command line. I can select default, and that's going to use the default location, which is the one I just opened in our WisDOT bundle. More likely, you're going to have your own CSV file that has the specific folder structure that you're looking for. And you have two browse options to find that. You can browse current, which will open up I'll just click on it, which will open up a select file dialog box. and it'll open to the directory of your current drawing. In this case, I have an unsaved drawing, so it's opening up our template location. We have a browse last. So if I click on that, it's going to open up the file selection window to the last location where you've used this tool. So wherever your last CSV file that you used is located, that's where it'll go. In my case, I'm just going to use the default. You can see I've got a bunch of folders that were created, all my alignment folders, and sure enough here, I've got my refinement and top folder created. The next tool is called Assign Object Layer Defaults. This tool is found on all three WisDOT tabs. Again, it's on that Common Manage panel. In the Layers menu, you'll find the button Assign Object Layer Defaults. So what this tool does is it assigns Civil 3D objects to the correct layer according to the drawing's object layer default settings. It gives you options to select multiple objects and select multiple objects in multiple ways. It's useful for a few scenarios here. One thing that we noticed a little while ago is that when you data reference a corridor in Civil 3D, that data reference does not go on the correct layer according to the drawing object layer defaults. So this would correct that issue for you. And then it also helpful in the scenario where you've renamed objects. So our object layer defaults take, for example, an alignment that you create. It creates it on a PALI layer, and then it has a suffix of the object name. Well, if you change the object name, then that layer is no longer correct, right? So it would update that for you. Next tool, one that you're probably already familiar with, is the Slope Control Editor. This is not a new tool, obviously, but we've made a new enhancement to it that I felt was worth pointing out. So we made an enhancement to this tool, and you'll see it in this red box here below on the Create tab of the tool. This allows you to create multiple control profiles at one time. So before, you'd have to type in one at a time up here on the individual section, start and end for stations and widths. And you know, if you've got a lot of these to make, that can be time consuming. And a lot of times you've got the same control profiles you got to make for every corridor drawing, that we wanted to be able to do this in bulk. So just to give you a quick demo on this one as well. Again, the control profile editor is found in the Design tab, and we're going to go again to the Design panel under Profile, Control Profile Editor. And you'll see it popped up here, and here's where I can do the multiple control profiles at once. Now we've got two options here. We've got the Use WisDOT default, or if you have your own CSV file set up for this, you can specify it here. Let me just open up what the default is. Again, this file is going to be found in our bundle. So I'll navigate there. And we've got our Create Slope Control Profile CSV file. I'm going to open that up. So all this is 4 columns. So we've got a column A is just whether or not we actually want to create a profile listed in here. So maybe I want to do everything except for this left DFS profile. I just get rid of that X mark there, and it won't make that profile. The second column is how the profiles are going to be named. So this is a profile suffix, meaning that the resulting profile is going to start with ZCP, the alignment name, and then this will be tagged on to the end. Now, if you're familiar with the control profile editor, you know that that tool only reads profiles that start with the ZCP acronym in the front. And then the default column is the default slope for that profile. So what it's going to do is it's going to make a profile that extends the length of your baseline alignment, and it's going to set that profile at this elevation. And then once you've got the profile created, obviously, then you can edit that, add different points to the profile, and set it up accordingly. And of course, then we have a description that just helps you understand what each of these profiles are. So let's go ahead and try this out. Let me expand. We'll do one for 25 here. You see, I don't have any profiles. I've selected 25 up above here. I'm going to use the WisDOT default. I'll hit create. You can see it command completed successfully. And if I expand profiles, there's all my control profiles. If I go to the edit tab, now you can see all those profiles show up here. And they have the default. They go from the alignment begin and end, and they have the default profile elevations already showing up in there. So that's how that works. Hopefully that just helps you get save a little time on having to create a bunch of these profiles one by one. You can do them all at once. Assign corridor targets, the next tool we're going to talk about. This one is found on the Design tab, the Design panel. There's a corridor menu. You'll find an Assign Corridor Targets button there. This assigns targets to your corridor regions based on a standardized naming convention. So again, this tool will reference a CSV file that'll map objects to assembly target parameters. We provide sample CSV files that coincide with some of our WisDOT standard assemblies. They're located in this directory here. I'll just go ahead and open up one of those samples. So if we go to our assemblies directory, you can see there's one here for beam guard, there's one here for driveways. Let's open up the beam guard one. And you can see what it does is it uses wildcards. So it looks for objects that meet the criteria of this object name. And you can see we have wildcards strategically placed in here. So you don't have to have the object named exactly like what's shown here, but as long as it meets this criteria with a wildcard, it'll find it. And then it'll target appropriately to the assembly or to the subassembly that's listed over here in the subassembly column. And then we have additional options in here too. So, you know, maybe I only want the tool to look within 20 feet of my baseline. I can put that value right here. So don't look any further than 20 feet to find this. Maybe I've got like 50 of these that meet 50 alignments that meet this criteria. Well, I only want the ones that are really close to the alignment. I can put that criteria in here. And then if I'm targeting multiple, I can do the farthest nearest type stuff here in the target options. And then if the target happens to be a feature line, we would tell the tool that that's the case using this column here. So the naming convention that we use in our standard CSV files is all based on what we outline in the FDM. Chapter 15.5.3 has all that laid out. So in the tool itself, in the interface, you would select your corridor. Then you'll get a list of all the baselines, and you'd select the baseline that you're most interested in. And then if your baseline has multiple regions, you would select which region you want. And if you're not sure which region each of these is exactly, you can use the Zoom to Region checkbox. So if you check that box and you flip through these regions, your model space view will actually zoom to the region that you've selected here. So you can just be sure you got the right one. Down below, you would select your CSV file. Well, let me back up. First, we have two options. We have an assign option and an export option. So the assign option is just what I talked about. We're going to assign targets to the corridor region. The export option takes an existing corridor region and it gives you a template of your corridor, of your region targets. So if you don't have any targets, it's going to have everything there. It just won't have the names of the targets. But this gives you a good starting point to populate that CSV file. You start with your region, export it, and then you can set your targets up accordingly. And then above here, again, assign, here's where you select the CSV file. You have an option to retain any targets that are already set. So when that box is checked, if you have any targets already set, it'll keep those. It won't like blow them away or anything. If you uncheck that, it's going to clear all your targets out and start fresh based on your CSV file. And then there's a checkbox of whether or not you want to rebuild the corridor after targets are assigned. We give you that option because some corridors can be quite large and may take a while to rebuild. You may not want to do that right away. You just might want to assign the targets, do something else, and then rebuild later. And then we give you a global target search distance. I showed you that column in the CSV file where you could set a search distance for each individual target. This is a global value. So maybe you want that to be the same for everything. You set it here. Maybe for just a few things you want it to be less than that. Then it would be, you'd set that in the CSV file. All right, shrink wrap corridor surface. This is probably one of my favorites and probably one that I'm most proud of at this point. This is really a pretty cool tool. I think we've all probably have gone through the struggles of creating corridor surface boundaries, having to do that interactive method, and you trace all the way around your corridor and you get done and it gives you an error or it just doesn't turn out right as you would expect. We're hoping that this tool is really going to help you just sort of get rid of those frustrations of creating surface boundaries for your corridor surface. So what it does is it creates a shrink wrap boundary for the selected corridor surface based on the selected point or link codes. So you can see in the dialog box here, we select our corridor surface. And again, this is only corridor surfaces. You're not going to actually, if you have other surfaces in your drawing, they're not going to show up here. This is only used for corridor surfaces. So you would select the point codes that the point and link codes that dictate what the boundary of your corridor surface should be. If you don't know which codes to check, most times, like probably 95% of the time, you can get by with just using this select by surface definition button. This will automatically find and select the codes that you need to create the correct corridor surface boundary for your surface. And then there's this region gap tolerance. So we wanted to build in the ability to have some control over whether or not gaps are triangulated or not triangulated between two baseline regions. I'll demonstrate that in a little bit, and that might become a little bit more clear. But sometimes you want it to triangulate, and sometimes you might not want to. So let's quick do a demo on this. All right, so we've got a small little corridor here. I added a gap here just to give you a demonstration of what that gap tolerance thing is all about. Right now I have my layers turned off. I'm just going to move my layer manager off to the side. So if you see something change, it's just because I turned the layer on and off. So let's start with a corridor top surface. All right, so this is right out of the corridor. No boundaries have been attempted here. See, there's no boundaries in here for these corridor surfaces, but we want to create one for the top surface. So I'm going to go to the WisDOT Design tab. I'm going to go to Corridor, Shrink Wrap Corridor Surface. And here our surfaces are listed. We want the top surface. And these codes all populate automatically based on what it finds in your corridor. Now, I think I probably just want my daylight code, but I'm not sure. So I'm just going to hit select by surface definition. So then this automatically selects all the codes that were used in the definition of my corridor top surface. I'm going to go ahead and click OK. And you can see there I got a nice corridor surface boundary. And you can see it automatically recognized that I had a gap here, and it went ahead and kept that. Now, what if I had a gap there, but really I wanted to triangulate across there? Well, let's just go ahead and do a quick measurement. See how far this gap actually is. That's about 25 feet, okay? Let's go back into the Shrink Wrap Corridor Surface tool. And again, I'm going to select by surface definition. Let's say I want to triangulate across that. So if that gap is 25 feet, well, I got to go bigger than that. Let's just go 30. So this is saying that any gap within a baseline, between two baseline regions that is less than this 30 feet, it will triangulate, okay? So I'm going to click OK on here. And now we've got the triangulation. Just want to show exactly what this tool is doing in the background because I think it's important to understand. I'm going to turn this surface off. So what the tool is doing in the background is it's taking each corridor region, it's building a surface around that region, it's building a boundary around that region. So what we have is a boundary for each region. So we got each curb return has a boundary. And then at the end, it's taking and merging all those and getting an overall boundary. If I go into the corridor, and go to boundaries, you can see I actually don't have a boundary in here, right? We are not using the corridor surface boundaries as shown in the corridor surface properties dialog. We're actually using regular surface boundary tools. So if I go into corridor 51 top properties definition, you can see what I've done here is I've added a height boundary that encompasses the entire corridor. So the first thing we do is hide everything. And then we add a show boundary to show just the areas that we want. So the result is the ability to show gaps if we want to. And we also end up with a nice tight shrink wrap boundary. So let's turn that back on. And I'm going to go back in the tool just to show that, what this tool does is it always overwrites the boundary that we have in here. So let's say I don't like this boundary, I want to start over. If I leave all this blank and hit OK, I'm right back to where I want. Okay. Let's say I want it to shrink wrap and I want the gap. I'm just going to use select by surface definition, and I'm going to leave my gap tolerance to 0. Click OK, and we're good to go. One thing that you may find when using this tool is situations where it doesn't quite show up as you'd expect. One example might be curb returns. It doesn't end up triangulating inside like the lane portion of the curb return region. When you see that, what's likely happening is you need to augment the definition that you've selected here, you might need to add a link code like top or possibly datum. So let's see what happens. So that's the top surface. You're probably thinking, oh, big deal. The top surface, usually I can just use the out-of-the-box shrink wrap. Very true, but the out-of-the-box does not account for gaps, so keep that in mind. But the real kicker usually is the datum boundary, because the datum boundary almost always requires you to do the interactive trace around your intersections all the way around and then cross your fingers, hope it actually works. This should greatly simplify that process. So I'm going to shrink wrap corridor surface. I'm going to keep my datum surface here. I'm going to do select by surface definition. Click OK. And there you have it. We've got a nice, clean, shrink wrapped corridor datum surface. All right, let's move on to the next one. Create cropped surfaces. So this is also found on the WisDOT Design tab, Design panel, the Surface menu, Create Cropped Surfaces. Out of the box, Civil 3D has a cropped surface creation tool. But there's a couple things that it doesn't do that this tool does. The first thing it is useful for is it allows you to do multiple cropped surfaces at one time instead of doing one at a time like you would with the out-of-the-box tool. Not only that, but it will also give you the option to assign a property set to the resulting surface. And in that property set, you can assign an alignment. Well, why would you want to assign an alignment? Well, then for quantity computations, we have another tool that I'll talk about that'll output the station range of that surface and the surface area of the surface. So this whole cropped surfaces thing is very useful for creating quantity computations that rely on 3D surface area. So to reflect changes from the crop surfaces that this tool does is you'd have to go through and rebuild each of the crop. You'd have to save the drawing, then rebuild each of the crop surfaces. So if you got a lot of crop surfaces because you got a lot of quantities you're figuring out, right-click, rebuild, right-click, rebuild, right-click, rebuild. A lot of tedious work there, right? So you introduce this new tool, Rebuild Surfaces, that allows you to rebuild multiple surfaces at once. So this is, again, as I put on the bullet here, useful for keeping multiple crop surfaces up to date. One caveat here is if there are any dependencies from one surface to another, you have to keep in mind that this tool is only rebuilding surfaces in the order that they're listed in the dialog box here, which is usually just fine for using with the crop surfaces tool. But if you were going to use this rebuild surfaces tool for something else that has multiple dependencies and the order matters, then this tool might not be right in that situation. And here's what I talked about earlier. You've got your crop surfaces. You've assigned alignments to each of those surfaces. Now you can get yourself a nice report in Excel that will give you the station range of the surface, the alignment name, and the area. And you can either report area in square yards or in square feet. So the 3D surface area tool is found on the Analyze panel of the Design tab. There's a QTO menu, and you'll find it there. Tool's kind of nice too because we give you the option to set whatever station precision you want, number of decimal places, and the same thing with the area precision. And again, the units can be square yards or square feet. Move pipe end. This is a tool that we originally introduced because oftentimes you might find in Civil 3D, especially with like if you're doing culvert pipes and you need to adjust the elevation of a pipe end, you can't really do that very efficiently with the grip edits. Let me just quick demonstrate what I'm talking about. So here I've got a culvert pipe, and I want to, let's say I want to move the center grip here of this culvert pipe end, maybe at the end of this this feature here. If I grab that and I try to snap to it, you can see you can only grip edit along the length of the pipe. Can't move the elevation. Let me go ahead and undo that. So again, we introduced this new tool called Move Pipe End. So now it prompts you select the end of the pipe to move. I want to move this end and snap to the new location. So I'll just snap up here. Now, what's great about this tool is it gives you some options. It asks you, do you want to move the bottom of the pipe to that location? That'd be the outside bottom wall, the flow line, the center line, the crown, or the top. So it's not just moving the center line of that pipe. You get to choose which part of the pipe you want to align with that location. So let's say, for instance, I want that to be the top outside wall. So I can click top, and then you can see there the pipe moved to that location. So a very handy tool for adjusting the ends of your pipes, specifically culvert pipes. All right, the next tool is called Rename Pipes. This one is also found on the WisDOT Design tab, Design Panel, Pipe Network menu. The purpose of this tool is to rename pipes mainly for storm sewer pipe networks. At least here at WisDOT, we name our storm sewer pipes with this naming convention. So upstream structure dash downstream structure, and by default you don't get that naming convention with your pipes in a storm sewer pipe network. So this tool just goes ahead and renames all the pipes for you, so you don't have to do that manually. You've got a couple options. You can rename one pipe at a time using the individual option, or you can rename the entire network at all the pipes in an entire network at one time. Pipe separation at structures. Again, this is in the same pipe network menu on the design panel of the design tab. The purpose of this tool is to check if you have enough separation between your pipes at a cylinder storm sewer structure. So we can't have pipes coming into a cylinder structure and not having any of that structure wall between the two. So we have a specification here at WisDOT that states that we need to have about a foot of distance between those pipes along the inside wall. This is a tool to check that distance in 3D to make sure you've got that appropriate separation. Next we've got, this is sort of a simple tool. It's just an easier way to open hyperlinks that are attached to objects in Civil 3D. It's called Open Hyperlinks. Doesn't really fit into any bucket, any particular bucket on the tab. So we actually have a drop-down menu in Civil 3D called Miscellaneous Tools, and you'll find it right there. So what this does is it gives you another way to open hyperlinks in Civil 3D that are attached to objects. If you do it with the out-of-the-box function to open hyperlinks in Civil 3D, the whole application minimizes. So let me just jump in and do a quick demo of what I'm talking about there. So here I've got a couple of blocks, and you can see if I hover on them, it says there is a hyperlink attached to open a photo, and it says control click to open the link. So I'll go ahead and do that, show you what happens. You can see Civil 3D completely minimized and my image then opened. So we don't want Civil 3D to minimize, so that's why we introduced this tool. Again, it's in the WisDOT Design tab. Over here on the Miscellaneous Tools drop-down menu, we've got Open Hyperlinks. Now if I just click on any of these, you can see the image opens up and Civil 3D stays active. The last tool I want to show is called Create Curb Offsets. This one's found on the Design panel, Design tab, under the Alignment dropdown. So the purpose of this one, it's very specific. It's got a very specific purpose, and that is to quickly create the face of curb and the back of curb alignments, mainly for planned production purposes, because we typically don't use those alignments for anything other than for displaying on our plan sheets. So this is really a tool you're probably going to use a lot when you're making your edge lines, your pavement edge lines drawing. You data reference in your curb flange line alignments, and then you use this tool to create those offsets. Let's do a quick demo of this one since it's our last one. Go down here to this intersection. You can see we have curb returns, and this is our, let's say this is our pavement drawing, our pavement edge line drawing, and we need to show our face of curb and our back of curb. So go grab the tool here, create curb offsets. So it asks you, what's the offset to the face? Well, in this case, it's 2 feet. What's the offset to the back? Well, this is a 36-inch curb, so it'll be 3 feet. And now I can select my alignment. Select my alignment, then it gives me an option. What range do you want to do, the entire alignment, or do you want to pick the range? Well, let's just try the entire alignment, see what happens. And it says pick the side. Well, we want this side over here. And there you go. You can see that this alignment for the flange must have actually extended beyond, and it was masked. So those alignments got created a little further than probably what we wanted. Let's try it again over here on this one. This time I'm going to pick the range. So I'll just pick one side or the other. And it doesn't matter what order. You can pick up station before down station and vice versa. It'll know what you want. Pick the side, and there you go. We get those curb return alignments. You know, if you got into a situation like this one where I didn't want it to go to full length, I can always just grip edit this back. All these are offset alignments. Bring it back. So you can fix that up if you did go beyond the limits that you wanted. So that's all I had for the presentation. I hope you find some of these tools are useful for working in Civil 3D. If you're ever finding any glitches or bugs that have anything to do with these tools, feel free to send them to our support mailbox. That's support.cae@dot.wi.gov. Or if you have suggestions for new tools to help make your work a little bit more efficient, feel free to send them in, and we'll take a look at it.